Okay.
Hello and welcome to the Design Make Play TV. I'm Sarah and this is Aryan, and we're both illustrators and designers at Zen Maker Lab.
And today we're going to use our sense of feelings to draw what is inside the magic hat. Whoa!
Whoa! So Aryan and I are going to try to do this drawing exercise, and we're going to use this magical hat to do that. So what I'm going to do is I'm going to use my left hand to try to feel what's inside of the hat, and I have no idea what it is, and use my right hand to try to draw what it is. So let's give it a shot. Okay, so feel up something here, and then oh, here's some bumps here. Hey, it's not. What'd you say it was? And oh, this is tricky. I don't know what. Okay, now we have a groove.
What is
now we have some type of thing here.
That doesn't make any sense.
What are you talking about? It totally makes sense. It looks like a flower pot thing. In the
top part is too complicated.
What is this? Okay, definitely feels bumpy. There must be some lines or like texture on here. I'm not really sure what that is.
What is this?
I'm not sure.
Oh, I think I know.
Really?
It's actually good job. Oh.
Okay, should we reveal what it is? I think I'm done. Okay.
Show the picture first and show the other.
This is what I drew. And this is what it is. As you can see, looks like I got a bit of the base sort of shape, but definitely not this beautiful face sculpted here.
Good job.
So now it's Aryan's turn, so let's grab another object and see how good you can do.
Okay, now it's my turn, right?
Yeah, let's
do
see what
it.
you can do.
Let's do it. Okay, 1, 2, 3. Okay, that's a tough one. What is this? That's a...
Hurry up and start drawing. Let's see what you can do.
Oh my god.
Go on.
Okay, I'm getting something. This is sort of, I know what it is.
Okay.
Somehow, like, there's a big
Looks like an egg.
part, isn't it?
Looks like you're drawing an egg with a leg.
Okay, this is...
Oh, looks like a chicken bone.
I think I totally...
Oh, yay.
That's good, right?
That's a chicken head. With a head?
I don't know if there is a head. I can't see a head. Like, there is a body, there is a leg, and...
You definitely have like
it.
You got the circles down. It seems like you know what you're doing, but I guess we'll find out and see.
Okay, I think I'm done.
You done?
So I got this.
Okay, now let's see.
Let's reveal what is it inside the magic hat.
Ah!
Almost there. But I forgot the wings. Oh, and it
And
was
it's a football!
but pretty close.
Yeah.
I say it's pretty close. But that's
Yeah.
a funny one.
Yeah. Well, now you can see what Aryan and I came up with. Mine was very different than his, but yeah, he did a very good job. I will give him that. He did a really good job.
We're gonna give 10 out of 10 to both of us, I think.
So I hope you guys had fun watching, and
try it at home. It's a fun game.
Yeah.
You guys can try it at home. You can grab a hat, pencil and paper, and tell one of your family members or friend to put something random inside the hat and try to feel it and try to draw it too. It's gonna be fun.
ENAC was the world's first fully electronic computer, and it was put together by some of the greatest minds in history, John Macaulay and one of my favorite mathematicians, John von Neumann. Now, this old computer used to take up an entire room, and it took great minds to program. But today, we no longer need computers the size of a room. We can do the same computations on something as small as this. I'm Zachary Anderson, and today we're going to be learning about microcontrollers. So, what is a microcontroller? Well, maybe a good analogy is to start with a computer. So on your computer, you can run a variety of programs. You can have a YouTube video playing while you're playing some sort of video game, and maybe you've also got, Word open because you're working on a homework assignment. Hopefully you're not multitasking like this. But these are all processes that require some computations, and each one is a separate task. A microcontroller is like a dumbed down computer that's able to perform a single one of these tasks, and maybe not at the same performance level, but at a simple enough level. And so they're great for applications in logging, moving actuators, and more. Now, microcontrollers are not just a full PCB like this. So when I say PCB, you can see that this is a fairly large chip, and there's some prongs at the end and a socket here. So the microcontroller is this little black chip right here. So this is the actual, basically, computer that's performing a list of actions in a sequence, right? So we can program these microcontrollers to do a variety of things. Now, they're great for performing, if you want to do some mathematical computations, that's okay. But they're better used for purposes where you want to automate things at a distance and probably using some sort of sensor, right? If we wanted to just solve some sort of math problem, we could probably just use our computers. It would do a better job and be a lot faster. But if you want to log data, or you want to, say, control the blinds in your room for some smart home automation, a microcontroller is probably the way to go. It's cheap, it's simple, and it's really good at doing that one single task. So what I'm going to show you guys next is how we can actually control this little microchip to perform a couple different tasks. So next, let's take our phalanges to the keyboard and do some programming. So you can take a look here. We're going to be writing some code for this microcontroller. So we're going to start with pin mode, and we're going to select our digital pin, and we plugged our LED into pin 2, as you guys saw. We want to set that to be an output. Next, what we're going to do is we're going to type digital write, and we're going to set pin 2 to be high. And then we're going to delay 100 milliseconds. And then digital write, pin 2 low, and then delay again 100 milliseconds. Okay. And we can go ahead, we can save that. And then in our tools here, we want to make sure that we've set everything up correctly. So our board is an Arduino Nano. The processor is an ATmega 328P old bootloader, so there's different bootloader types. And the port that we're connected to is COM port 8. So that all looks to be correct. So why don't we go ahead? So we're gonna see what happens when I click upload now. So are you guys ready? Here we go, let's do it. So I'm clicking upload. Oh, and again, I make this mistake. Oh my gosh. Don't forget semicolons at the end of all your statements. Arduino is actually written in C++, and so we have to meet that same syntax. So let's go ahead, let's click upload one more time. There we go. So we're probably going to see a couple of flashing lights on the board that shows that it's programming, and now you should have a blinking LED, which is pretty cool, right? So we got our blinking LED. This is awesome. That's always what I ask people when they're working on a project. What's your blinking LED? Blinking LED means you can go home, right? Yeah, so we got our LED to blink, that's great. Now we know about microcontrollers. We know that they're sort of like a computer, that they can do a single task. And we learned how to actually program our microcontroller to just make an LED blink. And this is an example of what microcontrollers are really good for. Microcontrollers are really good for automating these simple tasks. If you wanted to log data or say run some sort of simple automation. Thank you guys for checking out this Make segment. Remember to check out our ZenMaker Academy online, particularly the electronics course. In that program, you actually get to use some of the same microcontrollers in your projects. And so it's a lot of fun, and I really, really enjoy it. I hope to see you guys next time. I'm Zach.
Hello everybody, welcome back to the DesignMakePlay show. I am your co-host, Omar Salem, and today I'm going to be your coach again. So last segment we went over some body weight warm-up exercises and we explained the reasoning behind why we do those. Today what we're going to focus is on strength training. Now, why is strength important? Well, it pretty much helps you become a better athlete in every respect. Whether you're a football player, a basketball player, or you play tennis, it's going to help your game. Now enough of me rambling, let's get started. Alright guys, so to start off the strength training routine, we're going to do push-ups. This is an exercise that engages your pectoral muscles, also known as your chest and your triceps. It also engages many other parts of your body, but those are the main areas of focus. Keep your elbows in line with your shoulder blades, and then just descend and ascend, okay? Like so. Make sure you keep your back straight and your core tight. So none of this, and none of that, back straight. So I'm going to do 20, and then I'll show you a variation in case this is too hard for you. Now, if you can't do push-ups like this on all fours, get on your knees and bust out as many as you can until you're strong enough to do them standing up. If you want to make things harder for yourself, one thing I like to do is make a diamond with my hands. This is known as a diamond push-up, and it puts more pressure on your triceps, and it's good to switch things up too. So, same idea, just a diamond push-up.
You can see I struggle a bit more with this.
Alright guys, so that's our first exercise, and again, it works your upper body, meaning your triceps and your pectorals. Now, on to dips. Now the whole point of this routine is to show you that you don't need fancy equipment to get your exercise in. So what we have here is a chair. Very simple. I want you to get your hands on the edge of the chair, get your legs out in front of you, so your weight is on the chair, and then just descend and ascend, descend and ascend. This works the same muscles that the push-ups did, but it hits it a little differently. It's more dominant on the triceps in this case. So bust out as many as you can. I'm going to do 15 quick ones. Don't forget to breathe. Now, if you want to make this exercise harder, you can put something like books on your knees or a weight, something to add more resistance. If it's too hard, just stick with the push-ups until you're able to do this exercise. Now on to our core. Now what we're going to start with is squats, body weight squats. Squats are probably the most standard exercise to engage your lower body, but it's really easy to injure yourself, especially when you start adding weight. So we're going to show you how to do it properly. What I want you to do, get your feet shoulder width apart, keep your back as straight as you can, and then like this. When you're in this position, you want to balance your weight on the back of your feet, so your heels, and you, as best as you can, try not to let your knees pass your toes, and get as low as you can. So I'm going to bust out 20. If you find it hard to keep your back straight, you can get something like a hockey stick to just place behind your back and keep it straight. Now if you want to make things harder for yourself, you can jump. So same idea. In your position, again, you have a hockey stick behind your head. I'm going to keep my hands out in front of me as a guidance. We're going to do jump squats. Same idea, it's just a more explosive movement. If you're a basketball player or a volleyball player, you're gonna wanna do these. Now, to finish off our lower body routine, we're gonna do lunges. So, get your back leg, in my case my left leg, get the knee to the ground, and this leg out in front of you. You want your knee to bend at a 90-degree angle, like so, okay? And basically, with this leg, your quadricep, you're gonna push into the ground and try and get your body to the ceiling. So we're gonna do alternating lunges with our bodies. So one of those, so one on each side, counts as one. Let's do 10. All right, everybody, so we finished our lunges. We did 10 on each side. Now, much like we did with our squats, we're gonna jump to make things harder. As well, if you really wanna make things harder, once you progress, get weights, hold them while you do this. Basketball players and volleyball players, again, you're gonna wanna add this to your exercise routine. So let's go. Like that, and like that. Get your knee to the ground or just before. All right, guys and gals, now it's time for our core exercise. We're gonna start off with sit-ups, which is probably the most standard core exercise known to man. So basically, get on your back, knees off the ground, and you're gonna wanna propel your back off the ground towards your knees, but you don't wanna swing, because that takes momentum away from your core. It's your core bringing you off the ground, okay? So, I'm gonna do 20, and then I'll show you how to make it harder. All right, so that was 20. Now if you want to make it harder, you can grab an object like this. When I'm at home, I use a basketball. Right now I have a foam roller. Basically, once you've done your 20th sit-up, or whatever you can, get your knees off the ground, get your back off the ground, and twist from side to side. Picture your elbow driving into one side, and then driving into the other side. So, let's go. So now, we've done our sit-ups and done our twists. Now, time for the third exercise, called leg raises. You're gonna wanna put your hand underneath your bottom, legs out in front of you, get your head just off the ground, not up here, not resting on the ground, just maybe 5 or 6 inches off the ground. Same with your feet, and then up. And I know I sound like a broken record, but don't forget to breathe. Do as many as you can. I'm gonna do 15. If you want to make things harder, hands at your side. And don't forget to keep your legs straight. It may not look much harder, but believe me, it is. Lastly, we're going to finish with a plank. Now, this is similar to a push-up position, except instead of being on your hands, you're going to be on your elbows, okay? So we're gonna hold this for 30 seconds. Back straight. Hold. All right, so that was about 30 seconds, and that finishes up our core workout. We started with sit-ups, we supersetted that with twists, we moved on to leg raises and planks. What you're gonna wanna do is let's say you can do 20 of each. Do 20 of each, rest, and do them again. Do that about 3 or 4 times, so 4 sets. All right, everybody, thank you guys for tuning in. We hope you enjoyed these last 3 segments where we went through a warm-up, some bodyweight strength training exercises, and then a cool down where we did a bunch of static stretches, stretched out the muscles that we engaged in the 2 previous segments. So again, my name is Omar Salem. I am your co-host and coach. I've had a lot of fun with you, and I can't wait to see you in the next episode. Have a great day.
Hello, I hope you're ready for our math challenge for today. Today we have the ornament problem. Okay, so let's go ahead and break this down. So we've got this lovely, beautiful Christmas tree, okay? And we have all these little ornaments on our Christmas tree, but there are quite a bit. There are quite a few. Now, we could go ahead and count this out, but that might take us a little while. So I want to know how many ornaments are on this Christmas tree. And one way that I can do that, rather than counting them all out, okay, we're assuming there's too many to count, we can actually just use a sample, all right? So we're gonna take two assumptions here. We're gonna assume first that the decorations, the ornaments, are evenly distributed, okay? And the regions are evenly divided, okay? So those are our two assumptions, all right? And in our sample here, we can count, all right? Now this sample is smaller than the whole picture, but we can go ahead and we can count some ornaments here. 1, 2, 3, 4, 5. Okay, so in our sample, there are 5 ornaments, okay? So we have a sample of 5 ornaments, and we know that in this sample, this first region, okay, there's 5, but there are 8 regions in total. Okay, so we've broken this Christmas tree into 8 regions. We know how many is in one region, and we have these two assumptions. We assume that the decorations are evenly distributed, and the regions are evenly distributed. So now I want you to answer this question. How many ornaments are on the tree? Okay, we're going to want to look at this number here in particular, and this number here in particular. All right, so there's a little bit of a hint for you. But I hope you have luck with this question. Let's go ahead now and move into our segments for the day. Hello and welcome to our math solution today. So you remember we had the ornament problem, and now we're going to have the ornament solution. So when we left off, we had this Christmas tree, and we talked about counting all the ornaments being very difficult. And so rather than doing that, we are going to use a system to figure out how many ornaments are approximately on the tree. And we made some assumptions. We said that the decorations are distributed evenly and that the regions are divided evenly, okay? So when we talk about distribution being even, you can see here I've drawn a couple of little dots, okay? And each of the dots is a set distance away from the other, okay? So these dots are always, let's say, 0.5 millimeter or 0.5 centimeter apart from each other, okay? Like this. So that's what we mean by uniform distribution or evenly distributed. Okay, so they all have the same amount of space sort of between each other. And if I draw a box, what's kind of nice is if I draw sort of like a box anywhere in here, let's say that I draw it over this corner. Okay, I count 1, 2, 3, 4, 5, and if I move to that box, say over here, I'm going to count something similar. Let's see. Oh, sorry. 1, 2, 3, 4, 5, 6. And then in this box, 1, 2, 3, 4, 5, 6. Let's say that I move that box slightly up. I can move it maybe up here. And you're going to see that I kind of get the same amount. As I slide this box around, I always end up with the same number of dots in there. Yeah, so this isn't always going to be true. Okay, there will be times when we're off by a couple. But for the most part, it's always going to kind of average out around the same amount because of this even distribution. We can take advantage of that, and that's what we're doing here. So you remember, we talked about breaking this tree up into regions, just like my box here, okay? And we now know that these different regions, because of the uniform distribution, will have approximately the same number of decorations or ornaments in each box. So what we can do is we can figure out how many are in a single box, and then count to figure out how many will be in the total. So we know that there are 1, 2, 3, 4, 5 in our first box here, okay? And we know that there are 1, 2, 3, 4, 5, 6, 7, 8 regions. So the answer to how many ornaments are on the tree, we can say that it's 5 times 8, how many regions we have. So the answer will be something around 40. And if you're real keen, you can go ahead, you can count up all the ornaments and see were we correct? How many are approximately on the tree? There you go, that is your solution to our math problem today. I hope that you enjoyed, and I'll see you in the next one. Hello and welcome to our Maker Highlights. Now this is a segment of the show where we get to highlight some really cool projects that have been worked on by students here at DesignMakePlay or submitted to us by makers around the world. And today we're going to dive into 2 really cool projects. So let's go ahead and take a look. So first up we have Francesca's BFF. So this project, I liked this one because Francesca is making this for her BFF. So I thought that was pretty cool. And it's something that I really like to see in projects. Again, that altruistic thing of how can I make somebody's life a little bit better using the things that I know how to do. So that's what Francesca's doing. She's making a cool gift for her friend, letting her know that she cares and that she's her BFF. So very cool project. I really liked this one for that reason. But Francesca, awesome job. And next up we have Miles Castle. And this one was pretty cool. It's pretty technical. So let's go ahead, let's take a deep dive into Miles Castle. Whoa! So this castle was actually constructed by Miles, all using basic shapes. And we can kind of break things down and see a little bit about how we did it. So let's go ahead and we can duplicate some of these parts. And we can take a look. Let me see here. I can duplicate this one. Look. We can see that the level there is actually just repeated. So he just wrote that with the scribble tool, and then he's repeated it a bunch. And again, that's taking advantage of the duplication tool, right? These flags are made out of some flat boxes and some roofs that have been sort of stretched out. Again, very cool. These sticks are just cylinders, okay, again, elongated and made the right color. These are just some cylinders that have been actually cut away. So first we cut them hollow and then we cut a little door out for them. So that's pretty cool. The surrounding, I guess you could call them like the teeth of the castle, the pieces on the top there. These are all just boxes, right? These are all just boxes. Again, we've got sort of a flat cylinder for the inside of this very cool pillar here. We've got a door, which is made out of, I believe, it's just some spheres and a box. So that was pretty cool, pretty effective looking for a door. And then I really like these trees. They're pretty simple, but they add kind of like a nice touch. And those are, again, just a cylinder and an ellipsoid. So I really like this project, again, because Miles is taking advantage of the duplication tool. So he makes one part, and then he uses it all over the place. And those are some of the best designs, are these designs that are kind of modular, and you can reuse assets all over the place. So really great job, Miles, on your castle. So that covers our maker highlights. Unfortunately, we don't have time for our engineering trivia today, Shishan Wu, but I'm sure we'll have time for her next week. But without further ado, let's go ahead and dive into our interview for today.
Now, most people in the tech industry caught the innovation bug early on. These days, there are special programs offered to kids to cultivate that creativity. Well, Zachary Anderson is an engineer, and he's a lead instructor at the Zen Maker Lab. Zach, hi, welcome.
Hi, thanks for having me on.
You brought some really interesting things here. I am intrigued. Tell me what happens at your lab.
So at our lab, we design projects, we deliver programs, we do programs for both kids and adults. We also run summer camps, and occasionally we do some birthday parties.
Okay,
as well.
okay. For example, what kinds of projects would you make in class?
So these are some of the projects that we run on Pro D days and summer camps. So we've got Simon here, who is our talking head, and all these projects were designed in-house, so actually at our lab, just here in North Vancouver. So here we've got a talking head, and his mouth will move and his eyes will wiggle.
Okay.
We've also got like an MP3, a night light, and I've got some projects that I've got running here that I'm going to show you today.
Okay, please do.
Yeah. So let's start with this one. So this is our RC car, and this one's pretty cool. So we've got a motor here, 2 big wheels, a battery pack, motor driver, and we teach the kids in the program all about these components and how they connect together. And what makes this cool is the controller is actually on your phone. So
that is awesome.
Are already hooked up. We're ready to go.
I'm gonna just. It's a very narrow space you're working in.
All right. Okay. So here we go. We're gonna drive it. Whoa, 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 whoa. Oh boy. Oh boy. Yes.
Live television.
Live television. Oh geez. Yeah. So.
There you go. But I mean, obviously, if we put it on the floor, we'd have a lot more space to go.
We'd have a lot more space.
But the kids learn this ground up. So what age are we talking about? So typically getting in at?
Typically, we're talking about ages 8 to 12.
8 to 12.
8 to
okay.
12.
So what else have you brought?
I've also brought in an LED clock. So this is another project that we teach about, and this is a good opportunity to teach about light and how light works. So there's a difference between light emitters and light absorbers. So paints typically absorb light, right? So black paint absorbs your red, green, and blue light. These are light emitters. So what we do is we teach kids the difference between the two. And when all the hands are together, you've got a mix of red, blue, and green light, and it actually produces white light. So the different hands, the blue is the hour, the red is the minute, and the green is the second.
So they build that right from scratch.
They build this up from scratch.
What would you say is sort of the best way to engage your students?
So one of the ways that I engage students is I'll show them like a project that we've already done before, and they'll go like, wow, that's like super cool. And then what we'll do is I'll provide like missions for them. So that's one of the ways that I get them more engaged. And when you're getting kids to learn things, they need to be equipped. And one of the ways that we equip them is through discovery. We let them equip themselves.
Right. Well, I want to discover what's going on over at this end of the table because I'm intrigued by these little figures over here.
So these guys...
Come on over.
Oh, okay. All right. So these guys are actually... this is actually a model that I designed during a class. So I actually designed this during a class. So we teach one on movable 3D prints. And so all these designs are actually printed as one piece.
That's crazy, even with all the joints and everything.
All the joints and everything. Yeah. So we teach about the principles of 3D design. So you're taking into consideration the 3D printer when you're making a 3D model.
Right.
And so we take advantage of the fact that 3D printers can actually print at angles. So that's how we can create these joints that sort of interlock.
I love it. This is so Harry Potter-esque.
It is Harry Potter-esque. So
what happens with this?
In our electronics program, all our programs are project-based. So in this program, the kids are they're designing their own toy, and they're embedding electronics inside of it. So we use 3D printing as sort of the artistic element, right, to engage the kids. And then we're able to teach them about electronics and modeling.
What happens with this?
With this guy. So there's a little switch on the bottom.
Oh, I see. I missed the switch.
You turn that on, and then you can cast magic spells. Wingardium Leviosa.
I love it. I love it.
Yeah.
Okay. Well, you mentioned that it's for kids and for adults. How do you approach those kinds of things differently? I mean, I don't know. I don't imagine adults are coming in wanting to do magic wands.
No, not necessarily. More complicated.
Maybe they are. That's okay.
You can be a magician. You can come and roll. Come on. Yeah. So we provide some programs in modeling for like Fusion 360 and SolidWorks, and then we do have a big course that we teach on utilization of 3D printing. So a lot of elementary schools right now and a lot of high schools are picking up these 3D printers because it's the new hot thing, but they don't actually know how to utilize them. And a lot of teachers end up not using them really in their classes at all. But the problem is they just don't have enough experience with them, and they don't know about the principles. Now, I've spent a lot of time with the 3D printer. I can tell you I own two, and they're running around the clock all the time. So I've actually developed a course on 3D printing and 3D principles.
That would be fun to learn. But I mean, just getting back to the kids, why do you think it's important sort of develop these roots in STEM and tech courses?
So we don't just provide STEM courses, we provide STEAM courses. And the difference is STEM stands for science, technology, engineering, and math. What we're missing is the art. And that's the part that really engages the kids. And that's really important for innovation and creativity. Because we're moving into this industry 4.0 where innovation is becoming critical to, it's an innovation economy. So we want to get kids thinking creatively, coming up with new solutions. And so that's why we include this art into our STEAM, and that's why we're trying to get them started early on. So they get lots of experience in making things and failing and going back to the whiteboard and remodeling things.
Well, thanks for bringing some art and more importantly, some technology to our studio today. Expelliarmus.
Oh.